In this question, we have a polynomial p, which is given by px equals 36x cubed minus 15x squared minus 2x plus 1. Part A, we want to show that x equals negative a quarter is a root of the equation px equals 0. And part B, show that the equation px equals 0 has a repeated root. So let's write the factor theorem first. If pa equals 0, then x minus a is a factor of px. So for part A, we need to show that p negative a quarter equals 0. So we need to show when we substitute negative a quarter into the polynomial, we'll get 0. So we'll have 36 times negative a quarter cubed minus 15 times negative a quarter squared minus 2 times negative a quarter plus 1. When we simplify, we'll get negative 9 on 16 minus 15 on 16 plus a half plus 1. And changing these to a common denominator, we'll have negative 24 on 16 plus 8 on 16 plus 16 on 16. And when you add those numbers, you'll get 0. So x equals negative a quarter is a root. So the factor of the polynomial which would give that root is 4x plus 1. So for part B, we need to divide 4x plus 1 into the polynomial. So 36x cubed minus 15x squared minus 2x plus 1. So we should find our repeated root comes from the quotient after we've done division. So the first term of our quotient will be 9x squared. So 9x squared times 4x is 36x cubed. 9x squared times 1 is 9x squared. And subtract, we'll get negative 24x squared minus 2x. And the next term of the quotient is negative 6x. So negative 6x times 4, negative 24x squared. Negative 6x times 1, negative 6x. And subtract, negative 2x plus 6x would be 4x. And drop down the 1. So the last term of our quotient will be 1. 1 times 4x is 4x. 1 times 1 is 1. And subtract, we'll get 0 for the remainder as we expected. So our polynomial can be written as 4x plus 1 times 9x squared minus 6x plus 1. So we'll factorize this quadratic factor. We have 4x plus 1, and this will be 3x minus 1 times 3x minus 1. So this is your repeated factor here. So that will give the repeated root 1/3. And from the linear factor, as we saw, that is negative a quarter. So this is your answer. Thanks for watching.